Welcome back. As promised, in the previous video, we learned how to generate alcohols when you react a double bond with mercury to acetate, water, and sodium borohydride, right? In this video, we are going to learn, and if you keep in mind, in the previous video, when we reacted a double bond compound containing a double bond with mercury to acetate, we made Markovnikov's product, right? But let's look at the same compound this time. Okay, same exact compound, but this time we are going to react it with borohydride, which is BH3, boron trihydride to be specific, THF, again that's a solvent, and then hydrogen peroxide. The hydrogen peroxide should rekindle your memory. So this is very similar to the HBr H2O2 reaction that we have learned when we learned the first time around when we learned anti-Markovnikov's product, right? So I'm not going to go into the mechanism, but if you figure out what the product would be, I'm just going to rewrite it in the same color here. Okay, I'm going to leave the hydrogen. This already has one hydrogen, right? I'm going to write that in the same exact color and then switch colors to get the actual product. So again, we are going to add a OH and a hydrogen. These are what the elements that we are going to add to this compound. Where do we add them? Well, in the previous case, the OH was added to the carbon containing the least number of hydrogen, and the hydrogen was added to the carbon containing relatively more number of hydrogens, right? But in this case, the OH would be added to the carbon containing more hydrogens, and the hydrogen would be added to the compound, the side of carbon that contains least number of hydrogens, right? So that means our product would be the hydrogen gets added here and the OH gets added here, right? Very good. So that is how you do. This is an anti-Markovnikov's product, in contrast to when you use your mercury to acetate and sodium borohydride, we ended up with a Markovnikov's product. And in this case, when you use boron trihydride and hydrogen peroxide, you end up with an anti-Markovnikov's product. All right. So that's how you work with boron trihydride compounds. All right. So I'm going to stop the video here because we're going to get into a separate area that I don't want to mix with this, because I want to keep content separate, but I only want to say how each content is related to the other. Okay. All right. So stay tuned for the next material in this series.